Hey, is mobile CI/CD pipeline slowing you down? Well, if so, you're in for a special treat 'cause today's guest, Anton Malinski, co-founder at Marathon Labs, shares hard-earned lessons from scaling testing infrastructure and why healthy CI growth isn't just about speed. He covers a lot in this episode. You want to miss it? Check it out. Hey, Anton, welcome to the guild.
Thank you, Joe. Happy to be here.
Great to have you. I've been speaking to a lot of people in the industry, hearing a lot about what you all are doing there. I guess before we get into it, Anton, in your bio, your bio you sent me, you wore a lot of hats over your career. So I'm just wondering, what led you to where you are now?
Yeah, I guess the initial vector, I guess, is I started as a mathematician, specifically in the cryptography field. So, very scientific, very hardcore and very deep. And I never expected to go into software engineering, but I started working on, security solutions in general and started working around the software. I was like, I'm going to poke around a little bit. I'm going to take a stab at it. And working on it, I started to feel like, maybe it's actually interesting, tinkering with this puzzle of like how to build something. And it led me to kind of go into the mobile area where I started building, prototypes for mobile phones. They were getting very popular. So everything had to be on the mobile and spend a lot of time there. And you quickly realize as soon as you get to scale, like certain scale, that you can't just verify everything like that you've already built before. So you inevitably end up in this space where you need to verify stuff. And I started building this thing for a growing team where we were having growing number of use cases, features, bug fixes. All of this needs to be balanced. And I was building the CI/CD story, we need more hardware and then we need to write better tests and trying to balance this all at the same time. So, and this is how I kind of ended into this. I think previously it was DevOps, now it's platform engineering, whatever you want to call this field, but it's basically everything around the code that ends up on the production that users are actually using. So everything around it.
Love it. So why mobile testing? Why does it seem like CI for mobile apps is there's a lot of friction compared to maybe a web app?
Well, first, I guess where the pain starts is usually development cycle for web is very different from mobile. On web, you can, deploy it in several minutes. It's going to be deployed on your CDN, whatever you're using, Akamai, Cloudflare, whatever. But for mobile, every release really matters. It's like hours and days of trying to see if your release is going to be canceled by Google, by Apple, something is wrong. And so you really need to make sure everything is really working perfectly. And ideally, you also don't want the team to stop working. You might have 10 people in the mobile, you might have 50, and all of that. If all of them stop working for release, it's not really a good thing for the business. So you want to still continue working on the next features and bug fixes. So making sure that whatever you're doing in your code base is up to kind of, I guess, a certain level of quality is it's a growing pain. You either don't know about it yet, or you already know about it and you're on top of this game.
Once again, in the pre-show, you mentioned something about Agoda, I think is the company.
Yeah. So this is the company where I got most of the experience, I guess, with the ACI and the testing and specifically UI tests for mobile and building mobile farms. So I joined this company end of 2015 and I stopped working there around middle of 2019. So I'm 3.5 years experience journey. I started working as a regular software engineer and transitioned into this infrastructure person and the manager for the core operations team. And this is where I've built mobile farms with hundreds of devices on more for Android, kind of roughly I think around 80-90 Mac Minis that were running all of our workload and lots of different just regular Linux servers running everything from emulated space, for example, for emulated Android devices and all the microservices that are needed there.
Cool. Yeah, and I think you mentioned something about you had some sort of loop going on, faster test runs, more tests written, more info needed, optimization. Can you walk us through maybe what that loop is?
Well, I guess in Agoda, the whole story, you have to understand, when I joined, the verification story looked like you stop working as an engineer. Everyone stops working. There's this Excel spreadsheet with list of scenarios where everyone was sharing, and you have a kind of pass or fail. And for several days, the whole work stops and release is cut out for this several days. No feature work, no bug fixes. Everyone just goes through these scenarios, basically like monkeys. And you want to optimize this. So this is where we started. And I remember we had like maybe a couple of hundred Appium tests that were run kind of once a month. But if you run them once a month, they're all like always like half read. So like you don't have any confidence or anything. And where we kind of left off, like there's a whole journey in between. Like we ended up with like every commit being tested in under 15 minutes, everything including regression for all the different configurations for Android and iOS. So the loop of kind of development started as, we have this pain. How do we solve this? Is an iterative process. This didn't happen in a month. This didn't happen in 1 year. It took us like 3 years realistically to go from A to B. And at first we tried to address the first kind of pains with, trying to get dynamic CI runners. We just need build machines to even start running tests. And if they're hard coded, like it doesn't really work out of the box. So you need if you want 10 more, you have to get 10 more. And once you get this, you start running your tests, usually using devices on those build agents, right? You spin up an emulator on the build runner, and that kind of works until probably like 150, 200 UI tests, where it's growing to this time when like it just takes long enough and you don't have really good control over it. So you want to run it faster. And we found that adding more hardware to this, it just didn't help, right? Like you get more build agents, it doesn't really help. There is a nice trick around it that people usually use, with sharding. So you have, for those who don't know, like this sharding is basically a concept where you parallelize the load into like this bucket. So let's say you have 200 UI tests and you want to run them on in parallel with 4 different runners. So you get like 50, 50, 50, 50, get like 4 different jobs, execute them in parallel. And that's kind of, you get more hardware. You don't really get more hardware, you get more build agents. Like you really need more devices that you want to execute the tests on. And since you are using kind of build runners as your hardware, that's kind of how, I guess, like where the solution grows from. And yeah, so at this point, I think we're roughly at around like 1 hour mark, 1 hour and a half for running our tests. And we added more hardware and we hit this wall of like 55 minutes. Like 50, we give it like twice more hardware. It's still for not faster than 55 minutes. And we figured out that this is not a problem at all in the horizontal scaling. It's something else is broken there. And we're kind of concurrently figuring out how to write better tests and everything. But the main bottleneck was around kind of the orchestration of running this. And specifically, this is like test runner space, where it's a fancy way of saying scheduling algorithm, like scheduler that tries to schedule tasks on your CPU for the operating system. Same concept, just like you're scheduling tests for execution on lots of different devices, or emulators, simulators, real devices. And we try to work at that time. I think we experiment with a composer from Juno, with Fork, with Spoon. We kind of modified them for several months, and it just didn't work for us. It was still kind of hitting exactly the same limitation. And the nature of it is everything in UI testing space and in general mobile testing space is super flaky. Cables break, batteries die. There's just some new update that's coming from manufacturer, and it has a pop-up screen. I remember in our farm, and it just stops everything. You can't click on it through any kind of software method. You have to physically go there and disable it. So that, because the manufacturer obviously wants you to update the new firmware, but you're actually running a 24/7 service for everyone. So competing priorities. Yeah, and then we kind of worked on this, tried to sketch out a prototype for something that could solve our problems. And the main 2 things that were trying to address there were around the better kind of load balancing and parallelization. And then also kind of addressing real failures. So kind of prepare, not hoping for everything to succeed magically. We just prepared that everything will fail, devices will fail, test execution will fail, your tests are going to be broken. We just put it in the design. We have to work around this. And we basically came up with statistical modeling and put this into the software. And I remember our first test run that we started, it was already running everything in 15 minutes from 55 that we just couldn't break with adding more hardware. It's just impossible. So we found this spot where what the bottleneck was for optimization of this particular problem. And kind of we released this, then I remember it was 2018, I released this as an open source project called Marathon. And we continued kind of adoption of it internally. And we got into the state where developers were happy with the solution. So developers were like, oh, I can actually trust my tests because like every commit that I'm running right now is executing all of those tests. So like all of them are green, so I can trust them. And that means I can write more tests. And then in the next year, our tests skyrocketed from 200 to like 1,200 for both platforms. So this is like both, we use native frameworks, so like XCUI test for iOS and Espresso with a little bit of UI Automator for Android. And the number of tests skyrocketed. You obviously find more issues and you solve them. But this phenomenon that I'd never expected, that like trying to optimize the execution like only puts more load on like you're gonna have more test cases after that. So and that's kind of the barrier, I think, in general, like there's 200 300 test cases where I think a lot of companies are struggling.
So you mentioned different frameworks. Does the framework you use matter? Like if you use Appium as opposed to native, does that impact how you're going to scale, or is it irrelevant? You still hit these bottlenecks.
So I guess I'll start the answer to this question from the technical side. Appium is nothing more than the same Espresso and UI Automator and XCUI tests. So Appium is just an HTTP server that is built around exactly those same APIs. So whenever you're running Appium, you just have more layers of interfaces to exactly the same APIs as you would use in native testing. So as any system that is like, simple system is usually more reliable. Like the more complex the system is, the more failure points you're going to have. So Appium from that perspective is usually much harder to achieve, stable execution. It's not unheard of. I've seen companies that have like successfully implemented like thousands of Appium tests, but it is definitely a much harder effort compared to native tests. And even between native test platforms for Android and iOS, the resource usually in your test case, what you're gonna find an element by some ID or by text, you're gonna like do some assertion, like click on something, interact with it. So generally, iOS and XCUI test is 50% slower than Android. So at Agoda, I remember we standardized the format for all the test cases. So we kind of first more like had like a specification. We used YAML for it, but it doesn't really matter. So it can be anything. So we first specified whatever the test case should be, and then like engineers took it for the actual execution and implemented it in the actual native framework using page objects and everything. But it turned out like from the hardware resource planning perspective that exactly same cases take like 50% more on iOS, which was a surprise to me. I expected both native frameworks to be exactly as performant. And then if you add Appium on top of all of this, it's just going to be slower and less reliable. So that means you're going to spend more hardware on it and effort as well.
So you do have a background in mathematics. Yeah. Are there any real-world metrics you rely on to let people know your CI growth is healthy, or it's going to hit maybe a bottleneck?
Yes. So I guess in terms of metrics, you can kind of see, so from hardware perspective and in general infrastructure, I would call the first important metric saturation, from the 4 golden metrics. And in this specific case, like saturation can be queue time and the duration of your verification or the build, like how long does it take for you to execute your tests and how much are you waiting in queue until your tests even start executing. It doesn't mean that your queue time has to always be 0. It's just impossible by nature because any company doesn't have a normal distribution of everyone working around the clock. Usually, you clock in, you start writing some code, you push something, you test, then it's lunchtime, and then maybe at the end of the day you're going to push your last commit and you actually want to test the final thing. So usually you have those spikes in the load, and that's where the queue time starts to be non-zero. It's going to be like 15 minutes, 20 minutes. But unless you have lots of money, you don't want to set a goal of queue time being 0. It should be something realistic, like 10 minutes. It's not the end of the world, but it shouldn't be, throughout the whole day. Like you should have times where you really have resources for running something. And for testing duration, at least in Agoda and later on, with just Marathon as a project in general, through customer interviews, what I found is 50 minutes to 30 minutes is generally psychologically okay for engineers to spend on waiting until their code change is verified. So anything, like you can go for a coffee, come back, and you still be, in the context of whatever you were doing. If the like this green or red check in the CI is taking longer than 30 minutes, you probably are going to pick up some other task, right? Like realistically, you need to work on something. So you're going to switch context, and whenever that you actually get the result, you already forgot what you were working on. So like being in this flow state for an engineer is really important. So this time to feedback, this is where it starts to kind of accumulate. And especially if your checks take, I've seen teams where it takes like 2-3 hours, like you start to pick not one additional task, you start to work on 3 of them and juggle all of them. And it's a pretty hard way to work, in my opinion.
Oh yeah, even with vibe coding, I can imagine now it's even worse. 30 minutes, people are already writing 3 new features,
Yes.
Cool. So, a lot of times when we talk about development, we talk about shift left. And I assume it might be easier with web than it is mobile. Is it realistic to shift left when you're doing mobile type of development?
Yeah. So shift left, like I guess, like the whole phenomenon here, like is shift left can be described from production to staging environments, from staging environments to CI, and I guess we're focusing more on this like CI to local development loop, right? So for when building mobile infrastructure or a mobile platform, ideally you will, like whenever you say you run your test cases in CI and something failed, you don't really want to people have to like run it on very different devices. You want to build this thing as a proper service where like something failed on a device with a configuration. Let's say it was a 5-inch screen, this specific DPI, this setting, like this specific version of the operating system, and you have exactly the same API on your development machine. You can use exactly the same CLI tool, for example, or like web UI and request exactly the same device. If it's a real device, you can get exactly the same device where it failed. And this way you can kind of shift left the signal from CI to your local execution. I don't really like the pattern of trying to push for a signal. Like if you can run something from your local, and there is no real difference between CI and your local execution at the end of the day. So like if I want to check something, if it's working end to end, I'm just like my ideal user experience. I have a button. It just runs everything as fast as possible without any flakiness, without any kind of something unstable, and just gives me a signal. Does it still work or not? And in my opinion, it's definitely possible, but for 99.9% of cases. So there are those things where you really need a specific hardware. So what I mean by this is we obviously have to talk about, emulated and simulated devices versus real ones. So for emulated ones, you can spin them as much as possible. You can scale them. You can buy more servers for spinning up Android emulators, buy Apple Mac Minis for running your simulators. That's very cheap. But if you want like rare devices, let's say you want some Chinese device without Google Play services, you're not going to buy hundreds of them, and you're not going to buy like them for like scaled execution so that everyone can run all of those tests in like 15 minutes. And what I mean by this, so in our case, for example, in Agoda, we're running around 24-25 hours of tests in 15 minutes, and just simple math, like how many devices do you need at minimum to even achieve this? It's around 50, right? So like it's around 50 devices, the minimum you need. Like, and that's if you have multiple people doing this, like concurrently, 150 devices of the same model. Well, it's unpractical, and not from the perspective of it's a once-off investment. It's the problem of your users are changing devices. Whatever was popular 1 year ago, you bought those, like, let's say you bought those 150 devices. You check it now, like your top 15 devices that your users are using, they're different. You need to buy new ones. And like, what are you going to with the old ones? Like, are you going to recycle them? Like, and in a year, you're going to do it again? It's unpractical to use this at scale, in my opinion. It's like when the proper process here, I think, is when you see an issue, and usually you see issues on like real devices, first you try to really replicate it on a simulator and emulator. There are lots of APIs available now. There is like anything around network shaping, packet delays, throttling. You have all the access to the camera, including, faking video streams. You can mock GPS. There's so many things that you can do with sensors, even like for an accelerometer. and try to reproduce it on an emulator and simulator. If it's at all not possible, and there are cases like this, of course, shift it to the real devices. And that's where kind of balancing between those like real devices and virtual devices comes in. So how many things can you realistically reproduce on emulated devices? If most of them you can do, it really depends on your application. Some applications are just simple CRUD things around API. They don't have really use any specific sensors. You don't need like low-level access to the hardware. So most of them can be realistically done on an emulator. But if you're doing something very, very, very interesting, I remember I was working like on one app. It was a called book reader called Bookmate, and we were partnering with this company which was building this very interesting phone with an e-ink screen on the back of it. So kind of front face was LCD, on the back you had e-ink screen, and you can't emulate this. Like whatever you do, like it's just not possible. You're gonna have to test on an actual device, and there's gonna be some proprietary API. So there's only one way to develop this. Like you can try to abstract everything behind interfaces, but there are those cases where this really is just a requirement to use real devices. But again, for you want to try to strive for using emulated devices, because those ones are easier to maintain, they're cheaper to support, they are updatable. Like whenever the new version of the operating system comes in, you can just update the package and deploy the new version of the simulator and emulator. But with real devices, whenever someone even says like Samsung S25 or something, which specific version of this device does it mean? Because they are varied between different markets even. They might have a very different silicon on chip there inside. They might have very different modem chip. They might have very different firmware version. So which specific device are we talking about? And even in that case of updating firmware that I mentioned before, do you want to update your firmware? Because some of your users will update the firmware, and some of your users are going to say no to this firmware. So whenever you have a crash from a specific device, like, do you want to store all the different combinations of firmware that you just want to have at hand to reproduce the issues? So it's a very hard challenge. And
I was gonna say, it sounds almost impossible to plan.
Yes.
Even if you do as best you can, once you're in the wild,
Yes.
all bets are off. But mathematically, there has to be some way you can kind of have confidence in knowing you at least have
you try to do the best with what you can. So you're always limited by the resources. In this case, it's even just the basic budget, like how much hardware can you buy? How much hardware can you afford? So when realistically, the first constraint is this one. And the second one is like, how many problems do you want to fix for the users? You're never going to achieve perfect software. It's impossible. There's no such thing. If we had an algorithm to do this, like everyone would already be using it. So you want to try to do as best as possible for the majority of your users. And this is where it's super important to collect what your users are actually using for your application. Maybe it's a very niche application installed for a market, and only a certain number of devices are popular there. And this is where kind of trying to find a vendor who is going to give you those devices, like rent them out, like Browser Stack or anything like this, or if you want to buy them, comes into play, because you really want specific devices. Otherwise, you're testing your app on basically minority of the users, and you want to make sure that at least the majority of the users have a good experience.
Totally. So, I wrote my notes. I forgot to follow up with you. You didn't mention Marathon open source. Maybe a little bit more about what is Marathon open source, because I kind of skipped over it without following up.
Yeah, that's all right. So Marathon is when started as this orchestration and test runner in Agoda, where we were trying to kind of parallelize everything as efficiently as possible and try to handle flakiness as well. So Marathon open source project is basically this test runner. It doesn't have any good UI or anything. It's just this component is in this very large puzzle of trying to solve testing at scale, and basically because the ideal user experience, you have a button and you just have a result in a very short amount of time, right? So Marathon is just this test runner for Android and for iOS. That works with basically real devices and simulated ones, and you just give it your application, give it hardware, and there's lots of different configuration that you can do there in terms of the execution, but basically it tries to balance everything as much as possible. So if devices die, God forbid, or maybe they disconnect, it just works around this. The test run never stops. And it works in a very different way to conventional test runners, so to say, because most of the conventional test runners, they pre-plan everything. Let's say the test runner sees 5 devices. It's going to split all the tests into 5 buckets and, just continue executing until it's done. Marathon does it very, very differently. It doesn't expect the devices to even be there. It's just like whenever the device is free, it figures out what is the best statistically correct thing to do right now in terms of probabilities, and including the things around like tests failing. So 2 biggest things around test run that are usually unaccounted for. Test duration. So usually there is an assumption that all tests you take exactly the same amount of time. So like when you shard, for example, into 4 different buckets, you assume that 50-50-50-50 is exactly the same duration. No, because some of your tests are going to take 1 second for like checking your one widget. Maybe you created one widget, make a screenshot comparison, next test. But some of your tests are going to be scenario tests. They're going to be like very long. It's going to include auth. It's going to go like, you're going to make some, orders. You're going to go into your like basket, go order check. It's going to take minutes sometimes. So you need to account for those things. And the test runner has to understand that this test, for example, takes longer duration. So I'm going to schedule only one for this device, but these tests, for example, are very short, and I'm going to schedule them on a completely different device and all together batch them. So this is one thing that it accounts for. And the second one is just how flaky are the tests in general. So if it sees, for example, a test that has been stable for the last, it's obviously configurable, let's say 1 week, it's not going to schedule additional retries. But if it sees that the test has been always flaky, like it still passes, and most teams are very comfortable with the fact that if one of the retries passes, the team still considers that the test is passing, right? So we're in this mode where we're happy to pay additional cost for still having the test passing. And it just calculates the probabilities and figures out, I need like 3 retries so that I can make this test, or like at least one of them being, green. But there's also another mode, like if you want to fix that flakiness, it sells all the metrics to like a metrics database, and you can see like which tests are flaky. For example, in Agoda, we implemented the process where every week, like the team lead or dev manager receives the report for like your team has like this statistic for the flakiness of your tests, and you probably want to fix those because they are really affecting everyone. The problem with the flaky test is not that like only a specific team is affected. If you're running tests at scale, one test can basically make a bad day for every single developer because everyone is running everything. And this is where kind of having that statistic is very useful. So like you can schedule preventative retries rather than, running the test. It fails, I'm going to run another attempt. It just figures out I need 3 of them so that like one of them can actually pass, and schedules them concurrently. And then if you have enough devices, you can already get the same result by still paying kind of roughly the same cost, but much, much faster. And you can also implement runs for checking flakiness. So like when you fix flakiness, for example, how do you really know that you fixed it? I run it locally and it's green. Did they actually fix it? Like you really need those numbers for the probabilities. Like, for example, the probability of passing was 0.7, and I want to get it to 0.9. It means that I need to run this test 1,000 times on different devices, hopefully concurrently, and then check the actual statistic for my fix. Like, did it improve the statistic or not? And this is what the Marathon open source project also allows you to do. So it's kind of like this engine of scheduling test execution as efficiently as possible at scale. So where like real problems happen, there is always flakiness. It's always going to be there. Like it was there in the beginning of time. I believe it's going to be at the end. So you can only manage it and try to do the best you can, and as much as resources as possible that you can put it in.
Nice. So I first heard about you all from, I think Igor from Ingenious.io.
Yeah, I agree.
He raves about how fast this is. So what's the other aspect of Marathon? I know you have the open source, but I believe you probably have another business that also does maybe more paid option.
Yes. So kind of context there is Marathon open source started around 8 years ago. And like for the past around 3 years, I guess, we've been building this cloud offering. So the whole idea is like Marathon is just the engine. Like the thing that I wanted to build originally was this user experience of I just send my application, I just as many tests as possible, and I want to receive the signal as fast as possible, by signal being, what's actually failing, and I want the signal to be reliable. Unfortunately, it's not possible to do this just with the open source offering. You really need this knowledge around infrastructure, like on how to tie these pieces together and have a process around infrastructure. There's always this new updates coming from WWDC, and they're always breaking stuff around like all of this stack, unfortunately. And what we're building right now is basically this user experience where you just provide us the binaries, and we give you the results in under 15 minutes. So it does involve much more than the open source offering, but I know it's pretty popular. The open source part is very popular in the community. So lots of teams are using this. I think the largest number of tests in one run I heard was around 9,500, which I was very surprised to hear. Like, I didn't know the teams were actually building like this, such large test suits. But then it depends on like what you're building and what the business wants in terms of reliability,
Awesome. I hate to bring it up because a lot of people are sick of it, but AI, hear about AI a lot with web. Is there any features or benefits of using some sort of AI LLM to help in mobile testing at all?
It's very controversial, I guess. My personal opinion, I don't see yet any good place to put AI in the mobile or even development. So my reasoning here is like, if you're just starting out, it's much better to read the resources that are prepared like for everyone for the last several decades. Like they are targeted for people, by people. They are handcrafted. AI is useful to get something very quickly out the door, but you really need to have a certain kind of experience, maybe like at least 10 years of doing exactly the same thing, and then this thing can prototype something for you, and it's going to be much better than starting from scratch for sure. But you're still going to spend time on it. So I guess for experienced people, yeah, I can see some value in it. But the first place that comes to mind is probably writing tests. Like instead of, getting all, for example, all the setup for the test, setting up expectations for the mock server, setting up expectations on like preferences in your app and etc. But at the end of the day, the approach before AI was like, I'm going to write my tests in a way where like I can do this in one single line of code, put a JUnit rule here. I'm going to have like some specific functions to set up my database. So whatever you're putting into the AI as a query, as like what you want to achieve, was probably already done with some framework for testing, realistically. So I haven't seen yet anything that looks really interesting to me.
Okay, Anton, before we go, is there one piece of actual advice you can give to someone today to help scale their mobile CI/CD pipelines? What would it be? And the second part is, what's the best way to find or learn more about Marathon Labs?
Yeah. So I guess advice is here. First, really set up the expectations. Like the verification and quality space is really problematic because I believe like the only way to really achieve this, and you've probably heard this from someone on like one of the podcasts, is there's this Kaizen approach to quality. And all it boils down to is like everyone really needs to chip in on this to succeed. It's a long-term game. It's never like, it doesn't take weeks. It doesn't take months. It takes years to get to the next level in quality for almost every team. And you really need to buy in an alignment from QA, from engineers, from product, from senior management, that they like the team is going to be slower because they're going to do work on the quality. So things first, set up expectations. This is going to take a long time. And if everyone buys in, then proceed with it. If someone doesn't really want to do this, I don't believe it's worth it. Like just continue where you are. You're gonna do basically go uphill with a large stone. So then try the second, I guess, thing that I want to share is don't try to reinvent the wheel here. I've been this guy, and like I created Marathon because of the necessity. Like I didn't create it because like I just want to create a new project. So try to reuse whatever is there on the market, and I don't mean Marathon here. Like whatever you see as a solution, like any product, try to work with the vendor. Try to work with people who actually have like financial financial alignment to the product for the product to succeed, because usually internal platform teams, they do not have any effect on the business. Their impact is transitive. They're only helping developers, so the business is usually never interested in improving the platform. For example, like AWS does. Like AWS sells their platform, and hence they're really motivated for the platform to be very high quality. If you're going to do something internally, at best it's going to be some hacky prototype, unless you spend years on it. But where are you going to get the budget? So try to reuse whatever is there already on the market. For example, if you're doing mobile farms, there is the successor of the OpenSTF open source project, Device Farmers. Start with that. Try to use native tooling, but God forbid, don't go into this rabbit hole. And also use solutions that are appropriate for your team size and the project. So if you're just starting out, if you have 2 developers and you have a very simple web, like, don't use any farms. Just go and like spin up an emulator simulator on your build runner. It's going to serve you for the next like a year and a half. You don't need complex projects in the beginning. Like, maybe you want to think about the process of like how you want to write tests at that point, but you don't need complex solutions in the beginning. You can think about them maybe when your team is like maybe 10 people, 15. So use an appropriate solution for your scale. And regarding Marathon Labs, I think our main website, you can go to our main website, marathonlabs.io, learn about our business, learn about our product, and there's also a link there to the open source version, which you can just try it out, give us feedback as always. I'm staying always active for the community, so go to my Twitter. Maybe we'll post a link somewhere. I don't even remember the link, to be fair. So reach out to me.
We'll have links to all this awesomeness in the comments down below. Thanks again for your automation awesomeness. The links to everything of value we covered in this episode, head on over to testguild.com/A560. And if the show has helped you in any way, why not rate it and review it in iTunes? Reviews really help in the rankings of the show, and I read each and every one of them. So that's it for this episode of the Test Guild Automation Podcast. I'm Joe. My mission is to help you succeed with creating end-to-end, full-stack automation awesomeness. As always, test everything and keep the good. Cheers. Hey, thank you for tuning in. It's incredible to connect with close to 400,000 followers across all our platforms and over 40,000 email subscribers who are at the forefront of automation, testing, and DevOps. If you haven't yet, join our vibrant community at testguild.com, where you become part of our elite circle driving innovation in software testing and automation. And if you're a tool provider or have a service looking to empower our guild with solutions that elevate skills and tackle real-world challenges, we're excited to collaborate. Visit testguild.info to explore how we can create transformative experiences together. Let's push the boundaries of what we can achieve.
The Test Guild Automation Testing Podcast. With flutes and lyres the bards began their song. A tune of knowledge, a melody of code. Through the air it spread like wildfire through the land, guiding testers, showing the secrets to behold.